Welcome, welcome. Thank you for being here today. Um, as always, this is Agentic AI, where we build AI systems, ML systems. We learn, we build, and we ship. So today's segment is about learning. We're gonna be learning about a segment. I would say something very important while building AI systems, especially agentic AI. So we're going to be talking about vector embeddings. What is it? In very simple terms, what is it? So without further ado, on the agenda, we'll introduce the concept of embeddings. Then we'll manually create some embeddings to kind of emphasize the concept, give a graphical representation, then go through some similarity search, and then we conclude. So vector embeddings are very important. We just talked about a vector, we just talked about embeddings. Don't worry about those two words for a moment. But did you know that a computer cannot understand a word? Did you? Well, that's kind of funny because we've gotten used to talking to Siri on our phones. We've gotten used to asking ChatGPT questions, but still, you're telling me computers cannot understand words? Well, that's true. Computers cannot understand words. However, they can understand numbers. So we need a way of taking those words and turning them into numbers for computer to be able to understand. And that's where in AI development, vector embeddings come in. So what the computers need that to be able to understand words. And how does it do it? It turns it to numbers. And that gives it a lot of advantages because as soon as it's into numbers, the computer can now capture the meaning of those words. It can understand the relationship between different words. And in the end, it can even formulate the context, which is why, especially with large language models such as ChatGPT, this is why we can write to a computer on our screens. It understands the context, the meaning of our questions, and gives us a response. So now let's think about those words for a moment. A king, a queen, an apple, an avocado, and a table, and democracy. Which ones are more related to each other? It's very obvious. A king and a queen, they all represent a human being. Actually, that human being in a power position. So meaning they are very, very similar. Even though in the dictionary, king and a queen may be in different alphabetical positions, but in terms of meaning, to us as human, they are very close to each other. Similarly to apple and avocados. Table and democracy, not so close. So this is why in the next section, we're going to create these embeddings to see how now the computer can actually understand these words. Here, look at this. So if you look at the king and the queen, we are creating a point represented by three numbers. In the case of a king, 0.8, 0.4, 0.95. Queen, 0.72, 0.19, 0.91. These numbers can be anything. They are arbitrary. I just use these numbers for us to be able to represent them. But if you look at this, 0.8 and 0.7, the first number, they are very close to each other. Then if you look at apple and avocado, 0.1 and 0.2 are very close to each other. The same thing applies on those numbers in the second position and in the third position. So for people who have a background in computer science, then you can actually create these as arrays, and that's what the embeddings dictionary shows. So I would take a king, a queen, apple, and avocado, and we present them as arrays, or in normal numbers, we present them as points in the space. Now, are you getting excited? Let's look at them graphically. Look at this. Look at this graphic. Anyway, I'm very proud of myself. But you see, now the king and the queen, if you look in this space, are very close to each other. Avocado and apple are very close to each other. Let me play it again. King and queen, avocado and apple, very close to each other. Is this starting to make sense to you? Now, let me play it again. If the computer is looking for which words are close to each other, king and the queen are close to each other, avocado and apple are close to each other, and now the computer can tell with these numbers we've provided that queen and king are more similar and avocado and apple are more similar. Anyway, so let me add some bonus before I conclude the video. For people building agentic AI systems, you can actually achieve the same thing we created manually by using a package from OpenAI Embeddings. You import it. Then you also need to import a memory database. In this case, we are importing Chroma, which is also part of the Lanchain Chroma library. And the OpenAI Embeddings, you pass in the model. In this case, it's the text embedding 3 small. And once you've passed this model, you can then call the function from the Chroma database. You pass in a document. In this case, could be a PDF, could be an HTML, or could even be raw text. Then you pass in the embedding function, and then the vector store will store our words as numbers. Then in the last section, that retriever, we're just creating an object that's going to help us search. So the same way I may go in that space, if I was able to physically go in the space using arms and grab avocado, grab apple, touch the king, touch the queen, the retriever does the same thing under the hood. Using the similarity search, we will look at the words that are close to each other and find them. Now, we understand what vector embeddings are. We understand how computers are able to understand words. And hopefully you had some fun. And see you soon. Thank you.